Alright, so today's date is Monday, October 7th, 10/7. We are on factoring the greatest common factor because what we are currently doing for our unit guide, pull this guy up for Unit 3. Here's our Unit 3 guide. We have lots and lots of factoring. This is a weird unit too because we have a paper quiz. Khan Academy is too, I shouldn't say too hard, it's just being dumb. If you had to do the level of Khan Academy, not very many people would be able to pass. So we're going to have a paper quiz, paper test. We do have one Khan Academy quiz because that whole section is pretty straightforward. That means retakes aren't going to really be happening, so make sure you really know what's going on.
Why not?
Retakes because I have to remake a whole test, a whole quiz.
Why can't we use Khan Academy?
It's too hard. Do you want to do the hard version or the easy version?
I want to do the hard
Because we're challenging ourselves.
Yeah.
Ooh.
Okay, I mean, we could try doing it. I mean, the first lesson is the same way either way. So I love having the growth mindset.
But if you want to do Khan Academy, they can do Khan Academy.
I'll put it up online for you guys to challenge yourselves. We'll give you some extra credit instead of XP. Extra credit and XP, probably.
Wait, do you get extra credit if you take the Khan Academy test?
Yes, we'll give extra credit for the Khan Academy and XP as well. It's harder because, should I show you why I'm...
Wait, Miss
Yes.
No?
I'll give you guys a little preview. So, if I come back, let's minimize complex numbers. That was last unit. Let's go factoring using structure. This is one of the lessons that you have to be able to do. You have to be able to solve problems like this.
Oh, that's easy.
And it's not that hard, I guess. We could do it. It's just, I felt like it was kind of a waste of time.
So you're just going to give us the same problems but not use the paper?
No, I'm going to give you easier problems than this. I was planning on. But if you guys want to challenge yourself...
Can I try both and then figure out which one I want to do?
Yeah, but the whole idea is you should be doing the online homework if you're going to be doing the online test. Because I'm not giving homework on this stuff. I'm just making sure you know how to do difference of squares and you're good. This is using structure and doing a lot of fancy stuff that we're not going to be doing, like polynomial identity, no. Geometric series. I don't want to go over the geometric series formula. It's useful, but just not super relevant, I guess. Anyway, coming back to 3-1. So, objective, quiet raised hand. It goes to Caroline first.
Find the greatest common factor of polynomials and factor them.
There it is. Thank you, Oscar, for giving her 50 XP. You're tapping like crazy over there.
You're doing a great job, Oscar.
So some vocab. What do I mean when I'm distributing? Can someone give me an example and tell me why that's distribution? What's an example where you need distribution? Who has their card? I saw India first.
Okay, it would be if you had a 6, a parenthesis, 3 plus 5a.
Good job, India.
All right, and how that? Well, you haven't done the distribute part yet.
And that to distribute, you have to multiply both of them by 6.
Okay, so you get.
You get 18 plus 38.
There it is.
Plus 30, yeah.
That is what it means to distribute. So everyone is clear on this. And this unit should be kind of review from back in Algebra 1, which we didn't get to. So I taught you this last year in geometry because we had some extra time at the end of the year. So factoring, you should be able to do this. I mean, the first few lessons are all review. So when I say to factor, I mean to undistribute. So can everyone write down to undo distribution? Which means if I have 18 plus 30a, I need to now turn that back into, I have to factor out a 6, and then what's left over, so 18 divided by 6 is 3, 30a divided by 6 is 5a, so plus 5a, and I've gone backwards. I've undone the distribution. Hopefully this isn't too world-shattering to most of us. We've seen this a few times before. All right, so the greatest common factor. Who wants to take a shot at these blanks? It's the what factor that does what to both numbers. I'm looking for an operation word in here, like add or subtract, and I'm looking for a size number here. Can you figure out what the blanks hold? Ellery?
The largest factor that's like multiple or
Other direction.
factor
Starts with a D.
Oh,
Divide does both numbers. Okay, we'll give it to you.
Yeah, I did not see that.
You're good. You still get your 50 XP. Woohoo! Beverly got it.
Oh, you did! That's so did!
She wasn't even looking. That's how good she is. All right. So, thank you. So, again, there are 2 steps whenever you're doing factoring for my class. Step number 1 is factor out the GCF. Factor out the greatest common factor, which is abbreviated GCF, the acronym.
Isn't this the Ninja Star thing?
And then step number 2, as India just said, is Ninja Star, but we're not dealing with that yet. We will deal with that another day. I think it's tomorrow. Step number 2 is Ninja Star. Tomorrow we will deal with the Ninja Star. Again, today is all about GCF. How do we do GCF? All right, so in terms of finding the GCF, this is how to do step 1. We're ignoring step 2 until another day. There are 2 parts for getting the GCF. You have to find the greatest common factor of the coefficient and the greatest common factor for the variable. The coefficient is just your normal GCF. Does everyone know how to do a GCF? We usually have a warm-up for this. The coefficient, I'm just going to write GCF, and hopefully that will suffice. GCF, so if I have, as an example, 32 and 24, the GCF of 32 and 24 would be 8. That's what it means, the greatest common factor. What can divide both 32 and 24? Well, 2 can divide both of them, 4 can divide both of them, but 8 is the biggest thing. Exactly, the greatest thing that can divide both of them. That's what it means when I'm saying greatest common factor. And then for the variable, it's really straightforward. To find the greatest common factor for the variable, look for smallest exponent. So for example, if I have x to the power of 3, x to the power of 71, x to the power of 5, what is the greatest common factor of those 3 numbers? Shout it out. Sure. It is indeed x to the power of 3. Because x to the power of 3 is the smallest exponent. So the smallest, or the GCF for this one would be x to the power of 3.
Good job, India.
Thank you, Sam. I'll pause here, make sure you really understand what's going on. Coefficient variable. All right, we're moving on to example number 1. I don't want you to add or subtract or do anything. I just want to look at 2 different numbers, 2 different terms, rather, and I want you to tell me what is the greatest common factor of 8x to the 4 and 4x to the 6. I need a quiet raised hand. What is the greatest common factor of 8x to the power of 4 and 4x to the power of 6? You need to do both step 1 and step 2. Who still has their cards? All 3 of you have your cards. Oh, Beverly, you don't have. Okay, yeah.
Wait, is it 4? X? Oh. Did you hear that?
What did they say? 4x to the power of 4. It is indeed 4x to the power of 4. Everyone box it. There it is. That is the greatest common factor.
Good job.
Thank you. Beverly found the coefficient 8 and 4. The GCF is 4. For the exponent, she found the smallest one. Which is smaller? X to the power of 4, x to the power of 6, x to the power of 4 is smaller. There it is. It's that easy. Every single time. That's how you do GCF. You have 2 assignments tonight. One of them is doing types of problems like example 1 and example 2. They just give you a list and you tell them what the GCF is. The next, actually, you might have 3 assignments tonight.
Why?
One of them is even easier than this.
Just stress this out even more.
Wait, let's just go look at the unit guide. The unit guide says we have, factor monomials. It's even easier than that.
Please just make me go insane.
It takes roughly 5 minutes to do each assignment, so you have 15 minutes worth of homework that you will finish in class for most of you. All right, example number 2. GCF of 36y to the 8 and 9y to the 12th power is what? Only one person knows. 2 people know. Can I get 3? Can I get 3? Can I get 4? Can I get 5? Can I get 6? Who has their card still?
Me.
Sam, go for it.
It's 9y. 4? Wait, 8. Sorry.
It is indeed 8.
4.
Yeah, you got it. Thank you, Sam. Thank you, Oscar, for giving everyone XP. All right, so
I thought about it because
Yeah.
I compliment you and
Beverly saw it.
you should get XP or something.
oh yeah, I mean she should not be doing it during the lesson, but whatever, we'll give it to her. Oh yeah, by the way, if you solve that really really hard puzzle and you can put it back together, you can get 500 XP.
What?
Do I get?
Wait, what did you just say?
If you take it apart and put it back together, you get 500 XP.
That would be what's on the table last
No,
time.
I'm thinking about it.
I gave you your 500 XP already.
Jay, give me 500. Give me 100.
I gave you 100.
Yeah.
All right, I'll give you 400 more.
Wait.
He solved it and put it back together?
Yeah.
A few times, yeah.
Wow.
Are you putting it back?
So it's both Jaden and Chewy. Okay, 400. And
Okay.
where's Chewy? Oh, I can't. He's absent. Oh, someone remind me to get Chewy's XP later. All right, so these are the keywords. You guys probably remember this from last year. It was the exact same notes. When I distribute, I do what with the coefficients? Take a look. When I do 3x to the power of 2 times 4x to the power of 3, I get 12x to the power of 5. What did I do with these coefficients, the 3 and the 4? What operation did I do? Quiet his hand. 3 and 4 make 12. What operation does that? Nice and easy. XP. Emily. Multiply. There it is. Thank you.
Good job, Melly.
And what did I do with the the exponents? I had 2 and 3 and somehow made 5. What operation did I do, Aurelio? Add them, bro. There it is.
You're doing really good.
By the way, if there is no exponent to add, if I have x to the power of 2 and no x there, it just stays x to the power of 2. All right, still doing lots and lots of review. So factoring should go backwards. I'm going to factor out the GCF, and I find the GCF to be, what is this going to be, 6x. Well, I guess if I'm going backwards, I should be going to this. But if I go backwards, I can get 6x to the power of 2 is going to be factored out of 2x to the power of 3 plus 1. What did I do with the coefficients? Everything is opposite. You are undoing. Factoring is undoing distribution, so you're doing the inverse operation. Instead of multiply, it's now what? Quiet raised hand. What is the inverse operation of multiply? I see 2 hands. Can I get 3? Can I get 4? Can I get 4 hands? Can I get 4 hands? It's the opposite of multiply. Go the other direction. Ah, multiple hands. Yes, Cheyenne. It is indeed divide. Thank you, Cheyenne.
Good job, Shy.
Because if I had 12 for the coefficient and I divided by 6, 12 divided by 6 is 2. And what about the exponents? What is the inverse operation of add? You guys know this since you were in kindergarten, Brian. It is indeed subtract.
How fast did the AP regenerate?
6 per day. So notice that it was a 5, but because I divided by 2, 5 minus 2 is 3. So I subtracted the exponents. If there are any questions about what we're doing here, now is the time to ask.
Pretty simple.
And you can get your 250 Beverly after you put it back together. All right, so you are going to be doing example 3, 4, 5, and 6. I can help you with example number 3 here. We'll do it together. Can someone tell me what the GCF, the greatest common factor of these two terms are?
Can you scroll up a tad bit?
Of these two terms? Is there anyone that has their card still? Colby has his card. Siri has her card.
Which one of those?
Oscar has his card. Who has their card that wants to participate still?
The bottom two? 6 and 8?
Come on, more people. You have your card. Participate. What is the GCF of 6a to the power of 4 and 8a to the power of 7? That's 0, yes. Yep, you got 2, and then it's a to the power of the smallest one? 4. Thank you, Atziri. There it is. The GCF is 2a to the power of 4. I have factored that out. Now I need to do these steps right here, where I'm going to divide the coefficients and subtract the exponents. I have 6a to the power of 4. I'm now going to divide that because I factored out. I'm going to divide that by 2a to the power of 4. So someone tell me what this first term is right here after I do 6a to the power of 4 divided by 2a to the power of 4. Ellery?
3. Yeah, just 3.
Just 3. There it is. Because we subtract the exponents. 4 minus 4 is 0, so you really have a to the power of 0. Anything to the power of 0 is gone. It's just 1. 3 times 1 is 3, so we just write 3. And then the next coefficient, or the next term, 8a to the power of 7 divided by 2a to the power of 4. Yes, Colby.
4a to the third.
It is indeed 4a to the power of 3 because 8 divided by 2 is 4 and 7 minus 4 is 3. That is our final answer. Box it. You are doing this over and over and over again. I will tell you this. Sometimes there's no GCF. If there's not a GCF, just leave it. I'll repeat that because one of these examples has that. One of these examples will not have a GCF. Just leave it. Don't touch it. Just rewrite it. All right, good luck. Work with each other. All right, example number 4. Who's my volunteer? Looks like it's Jaden.
Wait, I just want to see if I got this right.
He's checking. He's checking.
Okay, I'm good. Should I just tell you?
Go ahead and tell me.
Okay, so you're gonna want to find that GCF feller, right?
Yep.
And we found him to be 5. And then you gotta throw in the B. And then you gotta put that 100 up there. Add those parentheses. Both sides. Okay. And then you divide 5 and 35, and you get 7B to the 100. Did I get that wrong?
So what's 100? What's 102 minus 100?
To the 2, sorry.
Yep, to the 2.
Can't read my writing. And then take away 4. Then you divide 5 and 20. And
Yep.
then the B's and the 100 cancel.
Yeah, because it was b to the power of 0. 100 minus 100 is 0, and then the b to the power of 0 is just gone, so it's just minus 4.
Good job, Jaden.
Thank you.
Thank you, Oscar, for tapping away like crazy. All these compliments and people participating. Who wants to do example number 5?
Throw it anywhere.
Sam.
Okay, so the greatest common factor is 10,
All right.
and then C to the power of 32. Okay, and then 3, C to the power of 2. Someone's mocking me. It's Jaden.
I was really writing down the problem. I was.
Sorry, Sam. Go again.
Plus 6C to the power 1. Minus 10.
Just 10?
Yeah.
Yep, you got it. Because it was c to the power of 0 again. 32 minus 32 is 0. C to the power of 0 cancels out. That's just not even written. Thank you, Sam. And finally, example number 6. Looks like we're going with Ellery.
It is. There's no greatest common factor, so it's just 3x squared minus 5.
There it is. You can't touch it. 3x squared minus 5 is your final answer. Can't do anything to it. Thank you. And Oscar's doing a great job back there. All right, so give me a fist of 5 for our objective today. Can you find the greatest common factor and then factor it out? Fist of 5 on our objective. I'm getting 5s, 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 4s, 4s, 5s, 5s. Is that a 1, Jaden?
No, I'm just
Yeah, so very high scores. All right, good luck on the homework. You should be able to finish in class because we get out of here at 2:18. You have 18 minutes left of class to finish the homework.